Hi everyone, this is Mr. Siu from Math Accelerator. Welcome to P5 SA2 Revision Lesson 4. In today's lesson, we'll be covering the topic on area of triangles. Let's move to the first question. Right, as we all know, area of triangle centers on one formula. In order to find the area of a triangle, we simply take the formula half times base times height, right? By applying this formula, we will be able to find the area of any triangle, right? But the condition is that the height and the base must be at right angle. Example, this is a normal triangle. The height must meet the base at right angle. Then you can use half times base times height. And the other type will be the right angle triangle. Right angle triangle, these two lines are perpendicular. We have the right angle here, so here will be the height and here will be the base. And then we have the third type, which is where the height is outside the triangle. So this case, here will be the base. You normally will see dotted lines as the extension. Okay, and we know that over here will be the heights, where as usual, height and base must meet at right angle. So this is the basic concept, okay, and the formula to apply in order to find the area of triangle. So let's see how we can use this to find question 1. ABCD is a rectangle. Find the area of the shaded figure. Right, the shaded figure, as you can see, consists of a triangle. So in this triangle, here will be the base. So in order to find the base, we see that over here is 10 cm, here is 4 cm. So we'll take 10 minus 4, we arrive at 6. So over here, the base is 6 cm. The height of this triangle, as you can, it is indicated here, is 8. If you can make it clearer, this is the height. It meets the base at right angle. So this dotted line is 8 cm. So now we can carry out the formula to find the area of this shaded part. So it will be half multiplied by 6 multiplied by 8, and we will arrive at 24 cm squared. Okay, once you're able to identify the height and the base, then it's very easy to apply the formula. Okay, let's see how we can use the same concept to solve question number 2. So in this figure, ABCD is a rectangle. Find the area of the shaded triangle. So this is the shaded triangle. In this triangle, we already know the base. The base here is 24. Okay, our job is to find what is the height here. Right, 6 cm plus this portion will give us 15. So the first thing to do is take 15 minus 6, and we get 9. Next, go right over here, 9 cm. Now we're able to find the area. The formula is half times base times height. Here would be the base. Here would be the height. So it's half times 24 times 9. So we will get 108 cm squared. Right, so these are the straightforward questions, normally what I call level 1. So let's move on to see how we can solve this question in level 2 of area of triangle. In level 2 of triangles are normally not so straightforward. You got to carry more than one step in order to reach for the answers, and it usually involves a composite figure. What's a composite figure? A composite figure is one that is a few smaller shapes combined into one. So this is an example of a composite figure. In this figure below, A, B, F, G, and B, C, D, E are squares. AD and AF are straight lines. AG is equals to 10 cm. The area of the square ABFG is 4 times the area of BCDE. Find the area, find the shaded area. So let's underline some of the keywords in this question. We have two squares. We have two straight lines over here, and AG is 10 cm. The area of square ABFG is 4 times that of the area of square BCDE. Okay, let's carry out the calculation. So the first thing you have to do is, let's look at this, okay, the shaded part. Okay, so we do not have a direct way to find this shaded part because this shaded part is not a regular triangle. However, we can see that this shaded part is embedded in two squares. And over here, we can see that these two squares will form the figure. And if we want to find the area of this shaded part, we have to take away this portion and this portion, right? So these three portions. So we can combine this portion, and this portion will be the first, we'll call it triangle A. And over here, we will combine these two portions to form another triangle here, right? So we'll call it triangle B. Right, this will be triangle B, this triangle A. So now that we established the steps already, so our strategy is, first of all, to combine the area of the big square with the area of the small square, and then we have to take away triangle A and triangle B. Let's try out our plan. So we will square. So in order to find the shaded area, let's write the word shaded area. We have to add the area of square ABFG with square BCDE, and then we have to take away triangle A and triangle B. Okay, so here's the plan. So now, are we able to find this triangle, this square? Yes, this square is, we already know one side is 10, so it should be 10 times 10. So we know that 10 times 10 will give us 100. So let's write here 100. And then the small square, we were told the smaller square is 4 times smaller than the bigger square. So this will be 100 divided by 4. 100 divided by 4 will give us 25. So now we have to find what is the area of triangle A. Triangle A is over here, is inside a square, therefore the height is 10, the base will also be 10, right? So we can calculate this part is half times 10 times 10. So half times 10 times 10 will give us 50. 10 times 10 is 100 times half, 50. Okay, the last one is triangle B. Right, triangle B, we do not have the actual dimension, but we can see that AB is 10 cm. Now, BCDE is a square, and if the area is 25, therefore, we know that length times length will give you the square, right? So we know we have to find a number that multiplied by itself that will give us 25. Okay. So if you're good at multiplication, you know that 5 times 5 will give us 25. So we can write here 5 cm. Here is 5 cm. Right. Another way to find 5 cm is you have a square root function on your calculator. You can press that, 25 square root, and you will also get 5. Right. So there are two ways to calculate the side of a square given the area. So now from here we can see that we can combine these two together. 15 10 plus 5 will give us 15, right? So we know that over here, A to C is 15 cm. So 15 cm will be the base of this triangle B, and the height is 5 cm. So we will take half times 15 times 5. So that will give us 37.5. So now, if we carry out this calculation, we will take 100 plus 25, minus away 50 and 37.5. Once you enter all this in your calculator, you should be arriving at 37.5. Right, so that's how we solve this question. So this is level 2. It involves multiple steps. What are the steps that we have taken? So number 1, we have to establish certain relationship between the bigger square and the smaller square, right? It centers on this. So we need to find the shaded area, so we have to come up with a plan, right? The plan that we have established is that this shaded area is inside the combined figure of the big square and the small square. So in order to find the shaded area, we have to find the total of these two squares and take away triangle A and triangle B. So triangle A, the height and base is very obvious, so we carry out the straight calculation. It's triangle B that is a little bit more challenging because we do not know the height and base. So we will have to look for other clues over here. The smaller square, as we know, is 25 cm square. So 5 times 5 is 25, therefore this part is 5, BC is 5, CD is 5. AB is 10, so now we're able to find the base of triangle B. 10 plus 5, 15. The height is 5, so we have the height and base. So after that, we calculate these 4 individual area. This is 100. The smaller square is 4 times smaller, so it will be 25. 100 divided by 4. Triangle A is 50, based on the height and base we have identified, and triangle B, height and base we have identified over here. That will give us 37.5. Once we carry out this calculation, we will arrive at 37.5. Alright, so we have to carry out multiple steps in order to reach the answer. And this is level 2. Of area of triangles. Let's move on to the next question. So here's the next question. So this is level 3. Because level 3 requires you to think slightly out of the box to find out the answer. So let me read the question first. Figure ABCDE has an area of 2,140 cm square. ABD and CBE are straight lines. Find the area of the shaded triangle BDE. Okay, what we can see here, we have two triangles. We have this figure. In total, 2140 cm square. We have two straight lines here, ABD and CBE. Find the area of the shaded triangle BDE, right? Which is this part here. Okay, so we have a triangle here, but we do not know the height of the triangle, so we cannot use the formula directly to find the area of this shaded triangle. However, we can see that we have some dimension here. We have 40 cm, we have 78. So the plan here is, if we know that these three parts, let's call it A, B, and this shaded part we'll call it S. All these three parts will combine to give us 2,140. So we're going to write A plus B plus S will give us 2,140 cm square. Next, we are able to, we have 78 here and 42 here. So we can find this triangle here, which is ADE. So let's calculate ADE at the side here. Okay, let's write here triangle ADE. Let's carry out this part first. It will be half times 78 times 42. And that will give us 1638 cm square. So this is B and S together, right? So here is B and S. So B and S, when we combine, okay, and we did a calculation, is 1638. So the objective is, if we are able to take away A and B, then we should be able to, from 2140, we should be able to find S, right? But we are able to have an opportunity here to find part A. So let's calculate part A first. So part A is 2140 minus 1638. And this will give us 502 cm square. So we know that part A is 502 cm square. Okay, next, we have a 40 cm, we have a right angle here, we have a 42. Okay, if we look closely, we're able to see that if we can make use of 40 and 42 to find another triangle. This triangle is CDE. Okay, let me have you see where is CDE. This is CDE. Right, CDE. So this is this triangle. So we also can see that in this triangle, A and shaded S, when we combine together, will give you this area of triangle CDE. And we can find triangle CDE easily by identifying the base of 42 and the height of 40. So let's carry out this calculation to find triangle CDE. So CDE will be half times 42 times 40. And we will be getting 840 cm square. Okay, so we know that A plus S will give us 840 cm square. Since we know that A is equals to 502, then we can do a subtraction, and we are able to find the area of triangle S. So 840 minus 502 and we will arrive at 338. So that's how we arrive at the answer. Alright, so this is level 3. Level 3 requires students to think out of the box, right? And to find how do we break the figure into separate parts and combine them into smaller parts so that we can find individual area. So in this case, let's recap what we do. First, we establish that there are 3 parts in this figure that will give us 2140. Part A, Part B, and shaded S. Next, when we write this, we are able to tell that B and S is one of the bigger triangle, which is at triangle ADE. So we proceed to calculate the area of triangle ADE, which is 1638. So once we put here, okay, then we find out that we're able to find the area of A, part A. Part A, we take the 2140 minus 1638, and we arrive at 502. So we know that A, we have the area already. Then we notice that we have 40 and 42. So we're able to find the triangle of CDE. Triangle CDE is 840. So triangle CDE consists of A and S, right? Part A and the shaded part. So we write an equation over here. A plus S is 840. Since we have established that A is equals to 502, we do a subtraction. We take away A from 840 and we find out that the shaded triangle BDE is actually equals to 338. So this is level 3. Thinking out of the box. Right, so that's the end of today's lesson. So we went through three levels of triangle questions to find area of triangle. Level 1, as I mentioned, is the straightforward calculation, where you just simply identify the height, the base, and you should be able to find the area of the triangle. Level 2, as I mentioned, involves composite figure. You combine multiple figures into one figure, and you have to carry out more than 2 steps or multiple steps in order to reach for the answers. Level 3 is the question right here, and in this question, it requires students like you to think out of the box. Okay, so how do we break up the shape? How do we find individual areas and combine them together to find the unknown part? Right, I hope you find today's lesson interesting and you have learned something new. So as usual, please remember to practice to gain confidence and mastery, and I'll see you in the next lesson.